Welcome back to a brand new explainer. Today, we are skipping right past the standard glowing stuff in the cosmos. You know, the stars, nebulas, and galaxies you're already totally familiar with. Instead, we're going on a little detective hunt to explore the hidden, invisible architecture of space itself.
It almost sounds like a sci-fi movie pitch, doesn't it? What if the most powerful forces in the entire universe are completely invisible to our eyes? Well, in astrophysics, we really can't just rely on things that glow. We actually have to look for the gravitational footprints they leave behind. Because when we look out into the night sky, those beautiful luminous objects, they literally make up just a tiny, tiny fraction of what's actually out there. The vast majority of our universe is dominated by an unseen side, just working silently in the background, completely shaping the destiny of everything we know.
Okay, let's dive right into this cosmic mystery. We're going to follow three main clues today: gravitational lensing, dark matter, and dark energy. We'll start with what we can actually observe, and then work our way out to the invisible engines that are quite literally driving the universe.
So let's kick things off with our very first major clue: gravitational lensing. Now, you might be wondering, how on earth do we find something that's completely invisible? Well, we look for how it messes with the things we can actually see. Think about looking through a thick glass of water. You know the water's there, right? Because the light passing through it bends, and the objects behind it look all warped and distorted. Out in space, gravity acts in a very, very similar way. A supermassive gravitational field acts exactly like a giant cosmic magnifying glass. It literally slows down and bends the path of light traveling from super distant stars and galaxies.
And this brilliantly illustrates exactly what we're talking about. See, a normal, perfectly shaped glass lens focuses light rays down to a single, neat little point. But out in space, mass is super messy. It's unevenly distributed. So a gravitational lens bends light paths in a much more complex, chaotic way. The light rays get crossed up, they diverge, and they never actually meet at a perfect focal point. And that causes massive, wild distortions in the image that eventually reaches our telescopes here on Earth.
Now, if you're the kind of person who loves peeking at the math behind the curtain, this is for you. This is the refractive index for a gravitational field. And what this formula actually tells us is absolutely mind-blowing. We usually think of light traveling at its maximum absolute speed through the vacuum of space, right? But when it hits a ridiculously strong gravitational field, the light actually slows down. It has to follow Fermat's principle of least time, meaning light will always take the path requiring the shortest travel time. So, to minimize its time slogging through this thicker gravitational zone, the light actually curves away from the center of the mass. Pretty wild, right?
Now, what's really interesting here is that we can see this exact principle happening right now out in the wild with the Abell 2218 cluster. Notice those stretched out, smeared elliptical arcs of light just wrapping around the center? Those are not just oddly shaped galaxies. Actually, scratch that. They are completely normal background galaxies, but their light has been intensely stretched and twisted by the massive gravitational field of the cluster sitting right in front of them. Astrophysicists call this weak gravitational lensing, and it's a total game changer. By measuring the exact shape and stretch of those arcs, astronomers can basically reverse engineer the picture to map out exactly where all that invisible mass is hiding.
And that brings us to the next massive question in our investigation. We see the light bending. We absolutely know there must be an unimaginable amount of mass out there to warp the fabric of space that severely. But here's the catch. When we add up all the visible stars, planets, and glowing gas in those regions, it is nowhere near enough mass to cause that kind of bending. Not even close. So what exactly is this massive, invisible scaffolding that's causing such an immense gravitational pull?
Our prime suspect? Dark matter. This is essentially the invisible backbone of our entire universe. Based on our best gravitational models, dark matter consists of unidentifiable point masses that simply do not emit, absorb, or reflect light. That makes them literally invisible to every single traditional telescope we have. Yet, they make up the vast, vast majority of the matter in galaxies. Think of it like this. Just as the planets in our solar system orbit freely in the sun's gravitational pull, these dark matter particles just sort of swarm freely within a shared galactic gravitational field, exerting a massive positive gravitational pull that anchors the whole shebang together. To really put the scale of this unseen force into perspective, just think about these staggering ratios. In our very own neighborhood, the Milky Way, all the billions of brilliant blazing stars you see, they make up only about 5% of the galaxy's total mass. 5%. The rest is overwhelmingly dark matter. And it gets even crazier. In some dwarf spheroidal galaxies, normal, visible matter accounts for less than 1% of the total mass. Dark matter is the primary boss in most galaxies, forming these colossal, invisible halos around them. And these halos are so gravitationally dominant that they actually reverse local cosmic expansion. They literally pull gas and stars inward just to keep the galaxy from flying apart.
So, okay, we've got a universe that is absolutely saturated with dark matter. Everywhere we look, there are these massive invisible halos pulling everything inward, exerting an immense positive gravitational grip, which naturally leads us to a massive plot twist in our cosmic detective story. If dark matter is constantly pulling everything together through gravity, why on earth do all our observations tell us that the entire universe is expanding?
Enter our third and final cosmic clue: dark energy. If dark matter is the universe's scaffolding, dark energy is its invisible, totally unstoppable engine. It's a deeply mysterious force, and to wrap our heads around it, we have to look at a super counterintuitive rule from general relativity. In relativity, pressure can actually act as a source of gravity. But dark energy? It exerts a negative pressure, essentially a state of tension. And in the bizarre upside-down rules of the cosmos, negative pressure generates gravitational repulsion instead of attraction. It physically pushes the very fabric of the universe apart.
So the crucial point all comes down to the seemingly simple little number, 0.5. For the first few billion years after the Big Bang, the universe was expanding, sure, but that expansion was actually slowing down because the massive gravitational pull of dark matter was acting like a giant cosmic brake pedal. But right at the cosmic redshift of approximately 0.5, the density of matter had thinned out enough due to that expansion that dark energy finally took the upper hand. At that exact epoch in time, dark energy took over the driver's seat, and the universe's expansion stopped slowing down. Instead, it began to violently, relentlessly accelerate.
Let's move to see how this builds up, because it really sets the stage for the ultimate cosmic showdown. On one side of the ring, we have dark matter. It exerts positive pressure, generating gravity, desperately trying to pull matter together to build magnificent structures like galaxies and clusters. And on the other side, we have dark energy. It exerts negative pressure, or tension, generating gravitational repulsion and relentlessly pushing the universe apart. Everything we know, every single star, every planet, every galaxy, us, we all exist right in the crossfire of this epic, invisible tug-of-war.
Which leaves us looking ahead to perhaps the greatest mystery of all. In this endless, invisible battle between the pulling grip of dark matter and the outward push of dark energy, what will be the ultimate fate of our universe? Will dark energy just continue to accelerate, eventually tearing apart every galaxy, star, and atom, or is there another massive twist waiting for us out there in the dark? We definitely don't have all the answers yet, but every single day, by studying the invisible clues left behind, we get just a little bit closer to understanding the true nature of our reality.